Hello students, here we have a problem where we have two long concentric cylinders. We have radiuses. Right now we don't have any numbers, but R2 is greater than R1, okay? Then we have the cylinders have equal and opposite charges. Let's say it's a lambda. So let's say the blue cylinder has a negative lambda 2, then the red cylinder has a positive lambda 3. Then we also have a thin rod that is passing through the center, and that one I call it positive lambda 1. Okay, so basically you have to find what will be the electric field, EA, where the radius of A is placed, let's say, like here, okay, something like this one. This is say that this will be our A, okay. Then we have to find electric field at B, which is located between the radius R1 and R2. And then finally we have to find what will the electric field outside of the cylinder, where it is more than R2, okay. So how can we find it then? First of all, I will not derive the equation. It's already was derived from the lecture. So I will go directly to the formula itself. So when you have such a cases, then general formula is electric field is equal to the lambda enclosed, so the charge enclosed, divided by 2 pi r epsilon naught. Okay, so first of all, let's find electric field where you have a distance A which is smaller than R1. So since we know that we have positive charge thin rod inside, that's passing through the center, then we want to find, let's say, electric field a distance of this one, okay? So that means you can say that EA is equal the lambda 1, because the charge, that is positive, like thin rod along the center, so I'll call lambda 1 divided by 2 pi, okay, and that distance A, okay, instead of radius, so that distance A times epsilon naught, okay. Now let's find before moving on, we can say that since the rod is positively charged, then we can say that electric field will be pointing outwardly, okay. If you do calculation, then you should find that you will get a positive electric field, therefore you can assume that it is going outwardly, okay, at that radius. Now then how can we find electric field at point B, the point B where it is located let's say between the radius R1 and R2, okay. Since we know that the charges that enclose it, the one which is in the rod and the thin rod which is in the center, and plus we have a blue cylinder, okay. So therefore we have charge per unit lenses, we have lambda 1 and plus lambda 2. Therefore we can say that EB is equal, the lambda is a general formula, so general formula divided by 2 pi, and the distance B, which is a radius, so epsilon naught. Now you have to keep in mind that this lambda has to be what? You know that you have thin rod and then cylinder, right? So therefore you say that it's lambda 1 plus lambda 2, right? Since we know that lambda 2 is negatively charged and lambda 1 is positively charged, and they have the same magnitude, therefore the sum of those things will be a 0. So therefore you can say that electric field and the distance between R1 and R2 is equal to 0, okay. Then finally we have to find electric field at a distance of bigger than R2, okay. So therefore then what will be then? We can say that electric field at the distance of C, then again we have to use first of all general formula 2 pi Instead of the radius, we have to put the c distance and epsilon naught. And now, how many cylinders and how many rods we have inside this a distance, okay, which is, let's say this one is, this is a c distance, okay. So how many of them charges we have inside? So we have lambda 1 plus lambda 2 plus lambda 3 and divide by 2 pi c distance epsilon naught, okay. Lambda 1 is a positive, lambda 2 is a negative, and lambda 3 is positive, so therefore we can say that this one with this one will cancel out, lambda 1 and lambda 2 will cancel out. Then finally you can say this lambda 3 divided by 2 pi c epsilon naught, okay. That's it, I think.